This is a lesson on implicit differentiation. It's the first lesson of Unit 4. Implicit differentiation. So what it means is you're used to functions being explicitly defined. So what that means is there's one variable solved by itself equal to a set of everything else. Implicit equations typically have more y terms, not always y equals 2, just like here's an example of an implicit equation. So we're going to differentiate these equations, okay? So you're still going to have all your rules for differentiation. It's just a little bit different when we take the derivative of a function that's not just y equals 2. So let's start out with something that we know how to do. If we look at this equation, y equals square root of 25 minus x squared, and we took the derivative of it. Use the chain rule, bring 1/2 down. Times the derivative of the inside, negative 2x. And this equals to negative x over okay, and what is this equal to right here? This just simply equals to y, which we'll need in a minute. Okay, all right, now a couple things we need to note. What happened to my y when I went from here to here? All right. If I took the derivative of a y, okay, so if I just took the derivative of both sides, then I would have, with respect to x, so if I went 1y to the 0, and that gets replaced by dy dx. So it's like me using and that just equals dy over dx. We differentiated y with respect to x, dy dx. We differentiated this, x, with respect to x, so you don't have to put it over here. Alright, so that's kind of a quick explanation of where this comes from. If you don't remember how, just remember what to do. So when I do the same function, x squared plus y squared, we'll do your x is the same, x squared, because you're differentiating it with respect to x, plus do the y the same, 2y, and anywhere you take the derivative of y, you put dy dx equals 0, and we solve this for dy dx. So dy dx equals negative 2x, dy dx, divided by 2y equals negative x over y. So see why I had to replace it so y'all can see where we got the same answer. Now which one was easier? Obviously this way. The derivative part of this is easy, and then you have to use algebra to work it all the way out. So let's play a little bit more with this. Okay, this is a circle on the right. It is given by the equation. You remember it's x squared plus y squared equals r squared, or in this case, x minus h squared plus y minus k squared equals r squared. So your radius is 5, so that's 25. My center is the point 3, negative 2. So it's going to be x minus 3 squared plus y plus 2 squared. And it wants us to implicitly differentiate it. So it's going to be 2 x minus 3 times 1 plus 2 y plus 2. Now the derivative of y is 1, but don't forget dy dx. Solve it for dy dx. I'm going to go ahead and distribute 2x minus 6 plus 2y plus 2 plus 4, and that whole thing is times dx dy. So I get 2y plus 4 dy dx equals negative 2x minus 6, or plus 6, excuse me. And that winds up dy dx, so you divide both sides by this, equals negative 2x plus 6 over 2y plus 4. Simplify it because we're fixing to plug them in a lot of terms. Factor out a 2, negative x plus 3 over y plus 2. Okay? So we're going to use these. We can find every slope of every tangent here. Vertical tangents. What do you think we're going to get at the point? What is that? Negative 2, negative 2. Or 8, negative 2. We should get a 0 in the denominator. So we get undefined here at the bottom, because if we plug that into our formula, we get a 0 in the denominator. And so that's why at negative 2, we have a vertical tangent. So let's go through 0, 2. 0, 2. Well, here's your point. Let's estimate 1, 2, 3, 1, 2, 3, 4. That looks about right. 3 over 4. Let's see what we get. Plug 0 in, you get 3. 2 plus 2 is 3/4, and we've already sketched that graph. 3, 3. Well, 3, 3, you know, is at the top here. That's going to be a 0. -2, we already found out that was our other vertical tangent. -3, or 3. We already know that that's our other horizontal tangent. -6, -2. -3/4. 6, 2, 6, 2. Yeah, so there you go. Okay. We can make an octagon out of this if that's what they want us to do. 6, -6. There it is. There they all are. Okay? Alright, so let's do more practice with implicit differentiation. And so this is just real quick, how do you do it? Y squared is 2y dy dx plus 2, or equals 2. The derivative of 2x is 2. The derivative of 3y is 3 dy dx. We need to get dy dx to the same side and factor out the dy dx. And then divide. Alright, so the derivative of 2x is 2. The derivative of e to the y, well, the derivative of e to anything is that anything, times the derivative of what's inside. The derivative of y is 1 dy dx. 2x minus 2y dy dx. So I'm going to get everything over here except for my dy's, dx's. Okay, so I'll put this in parentheses and I'll just have it times the dy dx. That goes away. Over here on the right side, I'm 2x minus 2. Here I got e to the y plus 2y dy dx. And there you go. Alright, look at this as the product rule. The first function is 2x and the second is y. The derivative of 2x is 2 times y plus the derivative of y is 1 dy dx equals 6y dy dx plus 2. So I get 2x minus 6y and the last step is to divide. There you go. Last one, more product rule. So here I go 15x squared plus 3, that turns into be 0. 2y derives into 2 times dy dx minus 6xy plus 3x squared. Derivative of y is dy dx. Distribute my negative. Combine these two like terms, add 6y to that side, 6xy, I get 15x plus 6xy equals to 2 minus 3x squared dy dx. Divide. And that's it. That's it. Now what values of x will this have a horizontal tangent? Take the derivative, set the derivative equal to 0, 3x squared plus 3y squared dy dx for x, or excuse me, for y. Derivative of 4xy, derivative of 4x is 4 times y plus 4x, derivative of y is dy dx. So now we want to simplify. There you go. What values of x will the curve have a horizontal tangent? So where does this equal to 0? So if I multiply the top and bottom by the denominator, it goes away, so 4y now this would be a horizontal tangent. And there's two values of x, but it's dependent on the y. In terms of y, I'm not going to do this. Horizontal tangent, you set this up equal to 0. Vertical tangent, excuse me, because that's got to be undefined. These down here are asking for the second derivative, so 2y dy dx plus 2 dy dx plus equals 2. Take the derivative one more time and get 2 plus 0 equals 0. And so there you have it. You could divide, so okay, so here's this one again. It's getting repetitive. I'm not going to do it. So there you go. You can do that on your own. And here's the fun stuff. So part A wants us to show that the derivative with respect to x is this. So we'll go A. And I'm going to take the derivative of 2x plus 2 plus 4y cubed dy dx plus 4 dy dx equals 0. Simplify. Divide. And simplify one more time. There you go. Write an equation for a tangent line. So you got your x, your y, you plug it in to get your m. Negative 2 plus 1 is negative 1. That turns into positive 1. So there's your slope, so y minus 1 equals 1/4 x minus plus 2. C, find the coordinates, 2 points of where the tangent line is vertical, so this has got a vertical tangent, means this in the bottom is 0. So 2y plus 1 equals 0. So y cubed plus 1 equals 0. So y cubed equals negative 1. So y equals negative 1. I want coordinates though. This is just where the y is. So in order to get the x coordinate, I got to plug it in the original. So x squared plus 2x plus negative 4, positive 1. It's a quadratic, so I'm getting everything to the same side. 2x squared, not 2x squared, x squared plus 2x, and I get 1 minus 4 minus 5 is negative 8. This factors into 8 plus 4 minus 2, so x must be equal to negative 4. X must be equal to positive 2, negative 4, negative 1 is one coordinate, 2, negative 1 is the other. Okay, so a horizontal tangent where it intersects the x-axis, so where it intersects the x-axis, y is 0. And then horizontal tangent tells me where the equals 0. So multiply the bottom. X equals negative 1, y equals 0. Plug it in and we'll be able to find out if it is possible. So x squared is 1 plus 2 times negative 1 plus negative 1 to the 4th plus 4 times negative 1 equals 5. That's negative 4. That's 1. That's negative 2. That's 1. That goes away, negative 4. Negative 4 does not equal negative 5, not possible.